Okay, so we're going to go through and describe what sort of motion this graph here shows going on, this distance time graph. What's the first section from like 0 seconds up to 1 second? What's happening there?
Nothing.
Nothing? What can you describe more than nothing? What's happening?
We're not moving.
Not moving? What's the physicsy way of saying not moving?
Is position constant?
Position is constant?
No distance is being traveled.
No distance?
Not in motion. At rest.
At rest, V equals 0. So it is a constant speed, but it's a constant speed of 0. What about this curve here, where the gradient's getting gradually steeper and steeper? What does that show? Acceleration. Good. We can't calculate the acceleration directly, but if we wanted to calculate that acceleration, we can calculate some stuff up here and work back to find out what the acceleration is. What about this third section here, where the line has a constant gradient? What's that showing us? Constant speed. Nice. Constant speed. And the speed is equal to the gradient of the line. If we want to find the speed on that piece there, we can calculate the gradient of the line, and that works because gradient is rise over run. The rise is distance. The run is time. Distance divided by time, distance over time, is the same as speed. And so speed is distance over time. And here we've gone from 2 meters per second, 2 meters up to 4 meters. So the distance is 2, and the time is from 2 seconds up to 3 seconds, just 1, 2 over 1, 2 meters per second. So a simple calculation to do from this sort of graph is to calculate the speed. Now that we know the speed here, we can work back and find the acceleration here, because acceleration is change in speed over change in time. Acceleration is the speed's gone from 0 up to 2. How much has the speed changed by? 2. So acceleration is 2 over, that took 1 second as well. 2 over 1. Acceleration was 2 ms minus 2. So acceleration, meters per second squared. Over here, what's happening when the gradient's getting less and less steep? What's that called? Slowing down, or a more sciencey, physicsy word? Nice. Deceleration. In the future, we're just going to call that acceleration, but we're going to say it's like in the opposite direction. It's negative acceleration, but in year 11 we're going to call it deceleration. Horizontal means constant speed of 0 ms minus 1, so at rest. Then the line getting steeper but going down the other way, what does that mean? Accelerating but moving in the opposite direction and moving back towards the start. Constant gradient sloping down, what does that mean? It's constant speed. What about the direction? Negative. Because it's sloping down, that means it's a negative gradient, so it's showing us that that speed is backwards. Constant speed backwards. And we can calculate the speed by calculating the gradient. So speed is distance over time. Distance has gone from 3 to 0, negative 3. Time has gone from 6 to 7, 1. Speed is negative 3 ms minus 1. What does the minus sign show us? Backwards. Yeah, cool. So the minus sign is showing us about the direction of travel.
Sorry, how come when you went from 6 to 7 with one gradient it's not negative 1?
Because time is going up from 6 to 7. whereas here the distance is going down from 3 to 0. Good question, though. That question just keeps coming back over and over and over again. I think we're done. We're done. We're done.